In number 1, we have a system of linear equations, and we're going to solve for x and y. Our main method will be to simply add the equations together and hope that either x or y cancel. In this case, if we add together the y column, the terms in the y column will cancel. Now, if that's not the case, then we'll do some basic operations of multiplying both sides of one or two equations by a number so that we end up with this situation where one column does cancel. So in this case, we're asked to solve for x, and we notice that if we add the equations together, the y columns cancel, and we'll be left with only x. So that'll enable us to solve for x. So add this column, and we have 2 plus 3 is 5, 5x. These two cancel, and that's good. That's what we want. And here we have 8. So we have x is equal to 8 over 5. All right, in this example, we're only asked to solve for x, so we're going to stop here. In number 2, we're asked to solve for y. So that means what we want to do is we really want to eliminate x. You see, if it says solve for y, that means that we would like the x column to cancel, eliminate x. All right, here's the x column. If we add together, these aren't going to cancel. We have 3x and x. All right, we don't have two terms with the same coefficient but with opposite signs. So we're going to do a basic operation. We'll multiply both sides, let's say, of the second equation by -3. Then we'll have a -3 here and a +3 here, and the x column will cancel. So we're going to multiply both sides by -3 so that the x column cancels. Okay, now rewrite the entire system. So the first equation I'm just going to rewrite, 3x minus 5y is equal to -2. And the second one, just multiply by that -3, minus 3x, and the second term also -3 times 2, -6y is equal to -3 times 4, which is a +12. Now we're ready to add the equations together, and we have this situation where the x's cancel. Here we have -11y is equal to -2 plus 12, that's 10. Divide both sides by -11, and we have y is equal to -10 over 11. Now we were asked to solve for y, so we're going to just stop right here. Remember, we were asked to solve for y, so we concentrated on eliminating x. We made sure that this x column canceled. In number 3, we're asked to solve for x, so we want to eliminate y. Let's look at the y column right here. If we add the equations together, we don't have opposite signs here, same coefficient with opposite signs, so we don't have a canceling situation. So we're going to, we would like to have a 6 here and a -6 here. So let's multiply both sides of this equation by -3 so that we will get that coefficient of -6 in front of the y. So multiply both sides by -3. And rewrite the entire system. So I'll write the first equation, 2x plus 6y equal 5, and the second one after multiplying by -3. So -3 times -4, we have 12x. Here we have -6y is equal to -6. So notice here we do have that canceling situation that we were aiming for. Okay, so let's add the x column. Add the y column. Okay, we have 0 equal to -1 on the right-hand side. And again, we want to solve for x. That's why we eliminate y. We have x left in the equation. So let's just divide by 14. And there we have it. X is equal to -1 over 14. In number 4, we're asked to solve for x and y. So what we're going to do is, we see that if we add the equations together, the y column cancels. So we'll start by adding them together. And in that way, y will be eliminated and we'll be able to solve for x. So here in this column, the first column, add together and we have 3x. And this cancels, and on the right-hand side we have 15. 3x is equal to 15. Divide by 3, and we have x is equal to 5. All right, now we want to solve for x and y, so what we do is take either equation. I'll just take the first one, but you can use either one. And substitute in the x value that we found, and then solve for y. So we have 5 plus y is equal to 10. Subtract 5 from both sides, and we have y is equal to 5. So in this case, both x and y are equal to 5. Let's do a check over here. The way you check is by substituting back into the original equations. Let's substitute back into the first equation. Here we have x plus y equal 10. We're substituting x equal 5 and y equal 5. 5 plus 5 is equal to 10, so that's correct. Now the next one, 2x minus y equal 5, so we're substituting 5 for x and 5 for y. We want to see, is that true? So we have 10 minus 5 equal to 5. Well, that's true. So that's our check. Okay, so this is our solution, x equal 5 and y equal 5.